Hey there, welcome. So we're back on oh, there I am. It's me in the video. Anyway, we're here talking about slope warping and we're back on the torso. So we're doing um our full body IK here in our function, and then we're doing some post full body extra pelvis offset. And we're also applying some extra spine 5 and head offset. So last time we were looking at these numbers and just getting those hooked up, figuring out based off what quadrant that we're in and what numbers that we want for our pelvis to either tilt forward or side to side or twist around. So here I built a couple of functions here that we're using. So this one is just for we get the slope or the roll value. I'm sorry, we get the pitch or the roll value, and it is just a simple. Let me open this up for you. It's just a simple remap node with a multiplier and an adder on top of it. So the axis that comes in is basically which axis that we're using off our Euler channel. And then the slope angle that comes in, you can see, is the slope pitch or roll that we want to look at. So depending on how the capsule is oriented to the incline, we are either leaning towards it to the side or leaning towards it to the front, or it's behind us, or it's on the right side. So on that slope value, we bring that in and we multiply that. So we get the raw value and multiply that by our remapped node. And so that we don't have to keep setting this up over and over again, we made a function for it. So we're just using our simple remap to multiply our slope value that comes in. So our slope angle is going to be our value here. That's multiplied by just the raw value that comes in. And then we're going to add that to our axis. So essentially we're saying, what is our slope and pitch? And our slope and pitch in Unreal, we start falling at 45 degrees. So we're either going to be at negative 45 or 45 on both of these. And then we're going to multiply those numbers, depending on what we want, by a value. So here on the pelvis, I wanted you to always lean forward on the pitch. So what we're doing here, if we simulate that, so we can see that if we start rotating forward or backward, and we can up these numbers. So let me just do this, get that off to the side. So if we wanted to do 5, we can like really lean forward, but we don't want to multiply that number by 5. And here we are also at, we watch this value, we're at negative 38. So the reason why it looks like this is because we're doing all of this information after the full body IK. So the feet are still in position to where we want them to be, more or less, because we're doing some, the foot placement node in the animation blueprint is after my slope warping stuff. So here we're at 5. So if we go to 1, we can see how we up that and we start tilting forward just to help with that balance. So I wanted, what was it, 0.5. If we just do 1, we can feel that a little bit more. And then here, when it's whoops, let's get our character back to 0. So now that we're leaning, the incline is in front of us, we're still leaning forward to catch our balance. So a negative 45 is going to produce a negative 45 number. So we're going to tilt forward. And a positive 45, since we have negative 1 here, we're going to also produce a negative number. So we're going to tilt forward on our character like that. So if we wanted to, we can say 1 here, and then we can start tilting backward. If we say 2, we can start tilting backward even more. But to kind of catch that weight and have that weight be over that front foot, we're doing a -1. So go to the floor and reset it. And then we can look at the roll. And the roll's basically the same way. So going to rotate on X. And we want to lean over the foot that is catching the weight. Just like that. So we're using these values here. So with the roll, we don't want to lean opposite, or we do want to lean the opposite in which it's going. So we've got, we do 1 here, 2, 3, 1. So what was that? 0.1, -0.1, and a 1 here, or 2, or -2. There we are. So that's why that number wasn't affecting it. So we're on this bottom one right here. So we're on a positive number. So if we watch this value, yeah, we're on a positive slope. So I think it was 0.1. And then if we go to, whoops, let's get this back. If we rotate and we're on a negative roll, now our negative roll comes in. So our source minimum is tagged to our target minimum there. So we have, say, 2, and now we're with the incline, like that. Or we can be against the incline, so -1, and then lean our weight towards it over the foot that's catching it up the hill. So I think it was -0.1, and we're just doing that. We say 0, then we're factoring in other rotations that we have there. So we don't need to do too much of an offset there for our extra offset. And we aren't doing anything to Z for an extra offset that pertains specifically to our slope in our roll. Let's get this out of there. So let's reset the floor. That's a 0, and that's a 0. So now we're talking about the quadrants. So we have our slope pitch alpha here, our slope roll alpha, and our slope yaw alpha. And then we have our new function here. And it looks kind of complicated, but it's basically a way for us to take these numbers here based off the quadrant that we're in and apply them to X, Y, or Z. So we see the X coming in up here. So if we take that, there's our X right there, our axis going up, our Y and our Z, and then we pipe that into our from Euler for X, Y, and Z, and then we get our rotation value there. So we started with these numbers here based off the quadrant that we're in, based off the rotational value or the translation value. So we have translation down here. If we want to move left and right, we have numbers that are affecting that. We want to move forward and backward. We have numbers that are affecting that per quadrant. And if we want to move up and down, we have numbers affecting that per quadrant. And then that's being piped into our X, Y, and Z over here. And looks like we're doing just a slight pitch here, a slight pitch offset to our, which value is this? To our Y, so that's our moving forward and backward, and a slight roll value to our X, and that's our side-to-side value. So here, if we do that again, if we show that, looks like I'm starting to pitch here, and we're moving backward, and we want to watch these values again here. So we're at a negative pitch, so we're closer to -45 here. And we're saying we're moving at a -5. So we say -10, we'll move even further backward, negative, say 25. Then we'll move even further backward. But let's say negative 500, that moves us a crazy distance. So if we say negative 75, so we can see how as we start to pitch forward, rotate like that, our pelvis starts to move backward. So that was negative 5. So if we come to a positive value for our pitch, whoops, and let's reset our character. That's going to happen a lot. So we're resetting our character, and we can see that we're moving our character forward slightly. We say if that's 50, see how she moves much further forward. So if we say back to 5 or 0 or negative 15, say we can move backwards or negative 15 like that. So I want her just leaning over that front foot a lot. And then we have our roll. So let's reset here. We'll give it a negative 15 here. Then we'll roll it some more. So we're at a positive value for our roll. That means we're here on our target because we've got our source maximum at 45, target maximum at 5. So again, that'll move us left or right. So let's see here. So if we change that to 50, so we're actually a positive number moves us down. We say negative 5. That'll move us over that front foot more. We were at a 5, so we're just moving slightly the other direction. And let's reset that. And then here, same thing. It's not, we are moving further down the slope. So negative 25, negative 50. You can see how we can move that there now. So here we're doing negative 5. But if we were to do positive, we'd lean so far over, we'd start getting a real nasty bend in our leg there. So negative 5 to move that down. So this is just a raw value. So we're not multiplying it here. We're just saying if our slope value is negative 45, then add another negative 5 to our X position. And same thing here. So here, if we're at a negative 45, we're going to add a negative 5 to our Y position. So that's one of the reasons why I didn't use this right here, because it has the multiplication factor there. And I just wanted a simple remap and add. Sure, we can change that into a function, but didn't. So that brings us to our quadrants. And we have our alpha values here for pitch, roll, and in yaw. We're using that down here too for translation. And then we've got our actual function that we're in. So we have two functions in here. So first, we're calculating which quadrant that we're in. And we're saying, if you're in this quadrant, do these things. And then we bring that through a quadrant interp. So in the interpolate, or in the quadrant interp function that we're using over and over again, so we use it 4 times per quadrant. I'm sorry, 1 time for each quadrant, so 4 times total. We're getting our values and then we're spitting them in. We're saying if we're in this quadrant, if our slope alpha is greater than 0, then we'll start affecting the value that we're going to have for this particular quadrant. And then I do that again here just for safety. So we have a slope alpha, number 1, and then we have a quad alpha, number 2. So depending on what quadrant we're in, we're either using this or we're not. So if we're in the front left quadrant, we have an alpha that comes into here that is either at 0 or greater than 0. So if I'm not sure if we'll watch this exactly here, so we won't watch it. But say we are rotating our character into this front front quadrant. So we're on the left, so our character's leaning to the left here. And then we're also going to be leaning forward. Whoops, here, forward here. There we are. So now we're in the front left quadrant here. So we can see our slope pitch alpha come up. So we watch that value. So basically, we're checking let's actually look at these alphas here real quick. So we have our set, slope, and quadrant alphas here. So if we hook this up, we get our slope. Which one do we want? We want our slope pitch alpha here. There we see it's at an 85. I can't point at it. It'll disappear. So how we're creating these alphas. So I set a variable here. It's a local variable. And just to say that if we're at a value of 25 or more on our slope, so it's just a number. It's just a float value. We're not. It's just a hard coded number. We aren't getting that number anyplace else, and it isn't derived from the game. So that is slope. Oh, it's a local variable. Go to our local variables. We click that and say slope source max. I set that to 25 because I'm setting it in multiple places. I didn't want to set it more than once. But yeah, you could have easily just typed in 25 here. So basically here we're saying we're taking our slope pitch value, and it doesn't matter if we're positive or negative. So we just want the absolute value here. And then we're piping that in. So we're saying if we're at a value of 0, then our output will be 0. But if we're at a value of 25 or more, then our output value will be 1. And that's how we're setting our slope pitch alpha. So here we can see that if we rotate backward a little bit more, we're just getting closer and closer to 0 on our pitch. So let's reset the floor. Now we're at 0 pitch, and our slope pitch alpha is at 0. But if we rotate either in pitch forward or backward, it doesn't matter. We will be getting closer and closer to 1. And as soon as we hit a value of 25, we'll be at our full value of 1. And the same thing with the roll. So we're going to hook this guy up. We see that reset to basically 0 there. There we are. And then if we add roll, we're going up or down based off our actual slope value, and then we're remapping those values to be constrained to 0 or 1. And then we have a slope yaw, and basically I'm just adding our slope pitch and our slope roll together. So if we are slope roll, put this in here like that. So if we're at slope roll and slope pitch, then we'll get whatever those two values are added together and divided by 2, or we're multiplying that by a 0.5. And then that'll give us our slope yaw alpha. Because our twisting that we're going to get with our yaw is based on whether or not we're rolling and pitching. So if we're only pitching, we're not going to twist. And if we're only rolling, we're not going to twist either. But if we're doing both, pitching and rolling, then, pitching and rolling, then we'll have some twisting. So that's how that's calculated. So that's how we're getting our slope pitch, slope roll, and slope yaw alphas. And then within that bigger function, so if we go back to our, here we are, set pelvis quad slope value functions, we are getting a value here that is our, sorry for just one second. Here it is. we're getting our quad front left alpha here. We're getting our quad front right alpha, our quad back left alpha, and then our quad back right alpha. So those are values from 0 to 1 again. So if we go back to our alpha function, we can see here that in our function, we are calculating our alphas, our quadrant alphas, based off of a couple of different factors. So we have our slope pitch. So if we remember, so if we go and look at the top of our character here, let's do this, 0 and 0 and 0. So it's all zeroed out. So if we look at the top of our character here and take a screenshot, we can see that over here, this is our front left quadrant. So if we just look at our front left quadrant here, let's pull that off to the side. So we're going to say that our slope pitch is greater than 0 or nearly 0. Again, this is a local value. But notice that these values don't exactly start at 0 the way I thought they would. So I took that value. So if we print this out again, and we get our slope pitch and our slope roll. Let's bring this over here real quick. And you can see from our floor, we're at 0, 0, and 0 for our rotation. So I would anticipate that our slope pitch would also be 0. So our slope pitch is 0 there. And our slope roll is 0 there. Well, that's fun. So that is not a number I was getting earlier when I was doing my testing. So I created a value that is just slightly greater than the values I was getting. I think it was like 0.0005 or something like that. So because that 0.0005 is greater than 0, then we are already activating like our quadrants. So I created this number here as a local variable. It's hard coded. Go up, down. Where is it? There it is. Local variable or nearly 0, and we're just saying that is a 0.001. So I guess that helps for just safety now. So we're basically saying if our slope pitch is greater than 0 or nearly 0, and our slope roll is less than our opposite, so our negated value, so a negative number. So if we rotate, let's see, which way is it? There we are. Nope, that's the wrong way. If we rotate that way on our slope roll, that is a positive number. And we're also in the on the right quadrant. So we want to be talking about the left quadrant. So we're going to rotate this back, and now we're going to the left of the character. So that roll is a negative number. So if we're rolling to the left in the front, then we have a pitch value that's positive, a positive number, and we have a roll value that's a negative number. So if we're both positive in pitch and negative in roll, then we'll be in the front left quadrant. And then we pass that through an alpha interp. So basically, we're just saying you here as a bool or a value of 0 or 1. So we're getting that value here. And then we're going to interp that result, a 0 or a 1 value, over time. So we're using the alpha interpolate node here. And we have a interp speed that's pretty low at a 3. So if we get our quad front left alpha, so let's get that. So quad front left alpha, and pipe that in, you can see that we're at a value of 1 there. But as we move out of that, we slowly move back to 0 because we're no longer in the front left quadrant. So I don't want to be calculating that. So like slowly as we enter the front left quadrant, so we're a positive pitch and a negative roll, that value will slowly increase up to 1. And as we leave that quadrant, we will slowly get to a value of 0. So those alphas are just basically, did we hit that quadrant? Yes or no? And if so, get me to 1. And if not, get me to 0. So we do the same thing over here. So let's just disable that. We do the same thing over here for our front right quadrant. So again, if we're in the front quadrant, we are going to be a positive value here. And this time on roll, since we're rolling to the right, it'll be a positive value. So we're looking at both pitch is greater than our nearly 0 and roll is greater than our nearly 0. That gives us our bool. We bring that through our interp, which has the same values here. And then we write our quad front right alpha. So if we hook that up too, just to see, quad front right, and enable. So we see we're at 0. We're leaning, as soon as I figure out where we are, we're leaning forward now. And now we're going to lean to the right. So now that alpha starts to go to 1. And you can see that in the corner there. We're at a value of 1. And then we're going to do that for our last 2 quadrants. So it's the same thing over and over again. It's just figuring out like what quadrant you're in, watching these values. Let's say we're watching pitch. Is that value positive or negative, depending on which way we're rotating? And what do I want to do with those numbers? And same with roll. So we know pitch is a positive value for being in the front quadrant, and we know roll is a positive value for being in the right quadrant. So that tracks for other say vectors that we can get. So like the front vector is positive, and if we want to be checking if we're going backwards, then that front vector is now negative. Same thing for left and right. If that right vector is positive, then we're moving right. And if it's negative, then we're moving left. So kind of the same thing here. If we're pitching backward, that pitch is going to be a negative value. If we're rolling to the left, that roll is also going to be a negative value. So here we're just saying, is my pitch less than our nearly 0 and negative? And is our pitch or is our roll less than our nearly negative 0 value? And if those two are both true, then we've got a 1 for our bool that we pipe in as a float value. And then we use our interp settings that we were using before to set our back left. And then we do the same thing here. Pitch is still backwards, so that's negative. And our roll is now to the right, so that's going to be positive. So we're using our negative value for our nearly 0 here, and then a positive value for our 0 here on roll. And we're saying roll is greater than our nearly 0 and pitch is less than our negative nearly 0. And both of those things need to be true. Then we've got our bool to 1, and then we have our alpha interpolate at our 3 and 3 there to set our quad back right alpha. Okay, now we've talked about our alphas. So we're back in our set pelvis quad slope value. So if we just look at the front right quadrant, so let's get those values there. Let's reset this, this, and this, and this, and this rotation here. 1Z. So here we're going to rotate bug. Which way is it? That's to our right. There we are. That's to our left. And then now, whoops, now forward. Okay, so now we're in our front left quadrant. So if we just type here, say 25 and 25, that should get us there. And let's reset our character back to 0. So now we're in our front left quadrant. So if we just look at our front left quadrant, because all of these are going to be identical, we're just changing out whether or not we're in the front right quadrant. And if we're going to be using the front right multiplier, and if we're in the front right, if we're using our front right alpha. So those are the 3 factors that we change out. So this one, and this one. So all of those are going to be specific to the quadrant that we're in. And then everything else is shared. We've got our slope alpha that's being piped in here. We've got our quad multiplier. That's just an internal function bool that says if we want to, how we want to multiply these numbers together. So let's look at that real quick. So we're piping in our multiplier here. So there's our multiplier. Say if I wanted to do something in the game and drive that value, we could. But if I wanted to hard code it, we also could also. Um, so I don't think we looked exactly at this function yet, but basically we've got our quadrant value coming in, our slope alpha. So our slope alpha needs to be greater than 0, and then we're going to start using our quadrant value. We're going to multiply that by a number, just in case we want it higher or lower, and then we're going to use our quad alpha too. So our quad alpha there is basically, again, to check which quadrant are we actually in at any given moment. So here, front left, front is positive, pitch is positive, roll is negative here. That makes us be in our front left quadrant. So if that's true, then our quad alpha will pipe up to 1, and then we'll start using this b value here. So now we've got our slope alpha. And our slope alpha is, whoops, let's go back here. All right, go back to our forward solve. We're here. And our slope alpha is based off what axis that we're working with. So the axis that we're working with is x. So the only factor that I want affecting x is our pitch. And on our roll, we're working with y. So the only factor I want affecting that for our slope alpha will be our roll, our side to side. And then our yaw, remember, our yaw alpha is a combination of we're pitching and we're rolling. So now if we're doing both in any value, then we will twist. So that's here, and that slope alpha is only going to affect our z value here. So if for some reason like something got out of control and we're in like the front quadrant, the front left quadrant, but like our pitch value is still at 0 for whatever reason, then we still won't use these numbers here. But that shouldn't be the case. If we're pitching forward, then we will, and we're rolling either left or right. We'll either be in our front left quadrant or our front right quadrant. So both of those things need to be true. So we're pitching and we're rolling to be in our front quadrant. So that might be a check that I don't need, but it's a check that's in there, and I'm just gonna leave it in there for now. Okay, so I think that should explain our quadrant. So we've got our quadrant coming in at B, our slope alpha determining if we're going to be at A or B. We've got a multiplier if we want to, and we've got a quad alpha to figure out if we're at A or B for that particular quadrant. And then we're setting up. So we've got our front left quadrant. So that's going to be this number that we're piping in right here. We've got our front left quadrant multiplier. So that's going to be right here. And then we have our quad front left alpha, which is just that raw value right here. We're not piping that in through the entry there. Um, so on this one, what we're doing is just an extra little bit. So again, we've got our front left quad moving into our quadrant value here. We've got our slope alpha moving in. We've got our, oops, here, we've got 3 values for our multiplier. We've got our basically our branch, our true false statement. Do we want to use our quad multiplier or not? And if we do, then we'll use our quad multiplier here for just this particular quadrant. But if we don't, we'll use just the global multiplier, which is down here, which is the multiplier that can be used across all quadrants. And then we've got the result of that true false statement, and then that's piped into our multiplier. And again, we've got our quadrant alpha, quad front left, front right, back right, and that's piping into our alpha there. And then we switch that up per quadrant that we're in. So front right quadrant, back left quadrant, those are changed, and our back right quadrant, those are changed there. So it's the same setup, just different values coming in. And then we put those all together and we add them all together and we add them to the axis that's being piped in. And then that's going to be our result. So the axis that's being piped in is just X, Y, or Z here. We know pitch is X, roll is Y, and Z is our yaw or our twisting. So we're adding our axis in together at the very end of that function and adding in all the quadrant values to that as well. Because if we're rotating forward, that's going to be good for our both forward left and forward right quadrants. And if we're rotating backwards, that's going to be good for our back left and back right quadrants for our x value. So all of that gets factored in for our x. So the actual numbers that we have are dependent on the quadrant that we're in. So this is just for x again, so just our pitching. So if we're in our front left quadrant, we're going to pitch a -10. And we're going to have a multiplier of 1 if we're using our quad multiplier. So let's say we're using our quad multipliers here. We're in our front left. We want to multiply that by 5. And we can see how that over exaggerates that number quite a bit more. And again, this could be a value that's piped in based on some sort of game. Like if we have gravity that's like if we have a higher gravity setting and that's putting pressure on the character and we want to show that exertion through how our character is tipped forward more and maybe how fast our character moves, we can start updating these values based off information that's being piped in from the animation blueprint. So I'm basically trying to um, uh, forward proof this for the possibility of some amount of scope that we might have later. Um, and since each quadrant has like slightly different numbers, we may want to use, our quad multiplier. But if we don't, we just use our global multiplier. We can say 10 here. So now we can see that we're at 10, or we can use our quad multiplier, and now we can see we're back at 1. But if we use our global, we can say 0.1 or 0 and just get rid of it completely if we want. So now none of this front quadrant stuff is working. But remember, this is only for pitch here. So here we would come to roll. We would say 0 there that we kind of pipe out. And here we would come to twist. If we want to twist more, we can twist more. If we don't, we don't. So you can also just change the raw values too. So we have to look at both of these. So we're at front left for our pitch, front left for our roll, and then front left for our twisting. And all of those values come together to make what this extra lean is here. So here we have a negative 10. So let me just duplicate these so I don't get the numbers wrong. Put that over there. So here we have negative 10. So let's say we want that pitch to be a little bit more. So let's say negative 20. We're going to pitch even more. So let's say negative 50 so we can really feel it. And then on the roll, so one of the things I wanted to do was get the weight of the character, so the head of the character to be over the foot that's catching the weight, which is that front left foot. So if we did a negative value here, then we start moving our weight away from that front left foot because we're on our roll, so we're on our y-axis there. So if we do negative 50, we can see how we're just rotating completely in the opposite direction. So the same thing with twisting. Trying to look at our values here. So we're at negative 10, 10, and negative 10. We do negative 10, 10. That puts us over there. And now to get that final twisting, so if we were to twist the opposite direction, say 50, like we're looking over that other shoulder. So in negative 50, then we're looking like way over that other shoulder. So it's just playing with these values here to try to figure out exactly how I want this character to be twisted, rolled, and pitched like that. So that way we can use these values and just type in a bunch of numbers based off the quadrant that we're in. So now let's look at the front right quadrant. So that would be I think, 25 here. I think a negative 25 over here. There we are. So our front right quadrant. So again, I guess one thing that I can show here is that we're also working with our translation here too. So we're looking at front right and we're moving side to side by 20. So if we look at front right here, so this is our translation. So same thing. We've got our slope pitch alpha here. Trying to figure out why pitch for our roll. It may not matter. I may not need anything here. If we're just a 1 there, and we just keep these values always up at 1. So 1 and 1. That way we let the quadrant alpha take control here. So we're in front right. So if we wanted to, we can multiply this by, say, 10. And we move our character, say, back down to the left. If we do negative 10, we just come the opposite direction. So this was 1, say negative 1. And we've moved our character up the hill a little bit more. And 1, we're moving him down the hill. But that's based off this number right here, so 20, because we're in the the front right quadrant. So if we say 0 here, so a negative value will move us to the right, and a positive value will move us to the left. So again, we're just looking for getting our character to show that it feels like she's over the weight and balanced, over the weight of her front foot there. So we probably could tweak that a little bit. So we're looking at yaw here. So twisting, negative 20. So let's try 10 here to twist kind of the other way. Maybe like a 5. And I kind of like that a little bit better, so we'll leave that there. So she still feels like she's leaning too far down the hill. So let's move her left and right. Here we are, left, right. So let's move her a -5 up the hill a little bit more, or a 0. Still want to move her just a little bit more. Let's try 5, 10. I like that one a little bit better. So I like once it's all set up, you can start using this for other states. And there's something nice too about not having to touch the animation. um, but again, like if you were going to do this with the animation, you probably could just do this with a bunch of blend spaces and additive poses, or different. Even if they're not additive poses, you can probably create a bunch of different idols based off like the locations or the roll and pitch values that you want, and get the correct pose that you want, based off like the incline and the weight and shifting and all that. So some of this is a thought experiment, but hopefully this will help you move in that direction of seeing how control rig can help you, even if you're hard coding these numbers, um, manipulate your character in a way that um, is beyond an artistic approach. Exactly. But I still think you need to have an artistic eye to see what you may not what you may need. So if we just look quickly at these other quadrants, so we're going to say -25 here. So now we're back left. That one feels good. So again, we are back left here on our pitch, back left here on our roll, and back left here on our yaw. And then for our left, excuse me, our translation, back left, forward, left and right translation, forward and backward translation, and up and down translation for our back left there. And then if we go to back and left quadrant, looks like we're going to fall over. So let's look at this for a second. This is our back right, I think, actually. So let's check it just to make sure. So if we look at back right, we're not moving this guy, but if we move it, oh, nope, we're not in back right. 0 looks like we're in back left. So that's a -10. Let's do -100. There we are. Let's do 10. Let's do 5 there. And have us lean more towards the wall rather than away from the wall. And let's move our character just a little bit forward, back left, quadrant here. I'm not sure which one's forward. Looks like that one is. So positive numbers forward. So that's, if we go -15, we go backward again. So it's like we're almost sitting. Let's try 10. And let's try 5. We want to start leaning to the back a little bit. So on our roll, back left, let's try 0. Let's try -50. Make sure we get a number in there, -500. There we go. So yeah, we want 15 here. Let's try 50 here. Looks like we might still be leaning too far forward. Let's not go that far. Let's go back to 15, and we want to set our pitch. Back left quadrant. Let's try the opposite, so 30. Maybe not that far. So let's try 40, 15, or 0. I still think we probably want to move down and backward a little bit more. So we're in our back left quadrant. we're going to move backward a little bit more. Let's try 10. Oops, negative 10, negative 5. Then down just a little bit more. Try negative 7.5. So then if we twist more, let's try that. Back left twisting. Let's try 0. That's negative 50. Like that. Works a little bit, maybe not that far. Negative 35. Here we are. Okay. So I think that will take us through our explanation of the pelvis quad slope value there. So we've got our extra offsets that we talked about earlier. And we have our spine offset. So again, we're using our slope value function here. So it's just straightforward. But to show it again, we are just remapping and being able to multiply our slope angle by a remap value of our slope angle, and then adding that to our axis. And then we're spitting out a value in our return. So for our spine offset, we're looking at pitch and roll. So here, let's watch these values here. So we're at negative pitch and negative roll. So if we go to negative pitch here, we're saying a negative 0.25. So let's copy these so I don't lose those values. So let's say negative 5. That's quite the adjustment. Negative 0.5. So looks like our pitch is trying to stand our character up a bit. So we say negative 1. So we're rotating backward like that to try to balance ourselves there. If we do a negative 5, we'll rotate back even more. So again, remember this is a multiplier at this point. So let's try our negative 0.25. But if we say 0.25, we'll start rotating forward and looking down. So negative 1, or 1, I should say. So we're just twisting our character to look more down a little bit. So let's try 0.25 there. And then for our roll, we don't have a lot of roll here. Okay, so for our roll, we can see this is a positive value. So let's just look at the positive value here. We're at negative 0.2. Let's try 2. We can see how we're starting to align to the incline. And here we're aligned perfectly with the incline. And here we're negating it. So we're just pushing it a little bit more if we go for a negative value there. So you just play with these numbers and see what you think feels good. We got a negative 0.2 there. And then we're doing the same thing over here with the head. So not much different. We're just offsetting the head a little bit based off where we want the head to be. So again, we're on roll. We do value of 2, and we're aligning to that incline exactly. I believe it was 0.35. Let's do 0.5 there. Now we can see how we're starting to feel like our character is standing up a little bit better. So let's go to our other map. That file. Been recent. We don't want to save. Cancel. That's not the right map. We want our slope map. So we're just going to open that up. Oh, and we're going to play. And we're just going to see how we like some of this stuff. There's something here that felt a little off. Might have been one of these quadrants here. But again, these are values that we can change as we see fit. It's probably this negative 35 here. It was a pitch value. We had negative 30 on our back left, like that. So basically these values like really only kick in. Actually, I should do that. Make sure these values only kick in if we're not moving, or multiply them by less if we are moving. I think I can do that because we have this function here. We can take this multiplier and then we can get, what is it, our ground speed. And then we have this multiplier come in and multiply it by our ground speed. So we remap our ground speed. And, these values will be dependent on like what your actual ground speed is. I think I can also do an alpha remap and say ground speed greater than 0. So it means that we are moving. And then we'll do a alpha interp. And if we aren't moving, this will be the value. We'll clamp this to a 0.25. So we're hooking our multiplier, and we're multiplying again by whatever this alpha is going to be. So here we're saying we want to clamp the result. So a 0, actually our in range and out range. And we'll clamp it to, no, we won't clamp it. So our in range is going to be 0 and 1. And our out range will be 1. I'm trying to think if I want this to be, because I want this value to be 1 when we're stationary. So we'll say is ground speed equal to 0? And if ground speed is equal to 0, then this would be a value of 1. And if it's not equal to 0, meaning that we have speed in the XY directions, then we're at a value of 0. So if we're 0, that means we're moving. And if we're 1, that means we're not moving. So if we're 0, we want the minimum value to be, because I still want some of it. So let's say 0.25. And then we're going to interpret those results. Let's interpret them at a slower value. Let's try 4. Let's try 6. Okay. So this value should be moving in and out of like 0 and 1. Actually, let's pipe this all the way to 0 just to make sure that we're going to get a 0 value here. And if we just watch this value here, watch value. Oh, since we're adding, actually that won't be accurate. Where are we? It's here. Here we are. There will always be a value being kicked out because the axis is adding those numbers. See, we're kind of twisting the wrong way here. Um, but again, like that is just something that we'll have to test. Uh, so if we're moving, it should be a value of 0 that we're adding. So we're not taking any sort of slope, extra slope on the pelvis here while we're moving, just out of that function. So the quadrant stuff won't matter. I think that's probably a good thing. Um, so I should probably use has acceleration, which is probably why I brought that in here. That way we basically just know when there's no input anymore. So let's come in here and say it has acceleration. So let's use that one. So we won't worry about speed per se. We'll just worry about acceleration. That way when I let go of the button, oh, and this is backwards now. So has acceleration. Then we want this to be 1 and 0. There we are. Oh, so whoops, we're not clamping the result. That's 0 and 1. We want the out range to be the opposite. So that's a 1, and then that's a 0. But that way, when we're moving around, that still feels wrong. Okay, when we have acceleration, we are moving. So that's a value of 1 that's coming in. Oh, map range. I need that checked. There we are. So by the time we get to a stop, we've already started to lerp back to our 1 value. So it isn't waiting for us to be at completely 0 speed. Okay. Cool. Looks like there's some things I've got to fix there. Like that's a little bit too far. I don't know what quadrant we're in there. Let's go out. Let's leave this. That's it. So we're getting an acceleration value from our APP, piping that in. And if acceleration is true, then we're at 1. That means we're moving. So that means we want this value to be 0, our out range. And then when we're not moving, we want it to be 1. And then we're interpreting that over time at this speed so that when we stop moving, we gradually take some time to decelerate and come to a complete stop. And that can help us move that 0 to 1 value for this alpha interp. So that by the time we stop, we're at a value of 1. So I think for when we're decreasing, we want it to be faster. Mm. Maybe it's the opposite. Because I want, like, when you start moving, I want to get that alpha back to 0 faster. I'm not sure. I'm not really necessarily seeing like a different result there. Okay. Next thing is like figuring out what's going on here. So we've got our slope and pitch. So we're negative and negative. So that means that this is a backward quadrant. So that's the back quadrant. Back back left, I think. So if we do back left quadrant, we just multiply this real quick by 5. Nope. Maybe by, oh, here we are. We use quadrant multipliers. Back left, we're going to multiply by 5. 0, 1. That's the pitch. I think we're really feeling it on the roll. So let's test it over here. 5. There we are. So we are back left. And the back left quadrant will be 15. Let's try 5. 5 feels better. So again, these are kind of hard coded in there. So here we're at a front quadrant, front right. So on our roll, front right, 0. It's interesting. We're getting different kind of slightly different results. What was that, a 20? So yeah, let's try a 5 here. We were leaning over there a little bit more. So just playing and testing with it and seeing where we're at. That one feels okay. Feels okay. Just keep just rotating around. Okay, cool. I think we're in a good spot. Let's double check some of these others. Might be a little too far forward there, but the neck looks like it's over the ankle. Let me move this down a little bit. See if we can get some other crazy angles here. That one's a little much. Let's do here. So our left front quadrant on our roll. Front left, 10, 20. Let's do 7.5. Let's try that. Then let's see our roll here. We're negative. So we're keeping that. So let's say 1. Aha. Okay. 0.2. Sorry, 0.3. 0.5. It's a little bit better. Let's try 0.35. It's not too high. I don't want a lot of adjustment there. Then same thing with the head. So we do 1.1. It's a little bit better. Let's try the opposite. If I can get her over there. So again, we're just looking at these numbers and playing around with like what sort of seems right. If there's any sort of position that feels like she's not balanced. So what are we looking at here? I think this is a translation I want to touch. So we're front right. We want to move side to side. If that's a 10, we say 0. Let's try 5 there. Then we do want to rotate a little bit on the Y. So front right. We do 5. Try 10. -5. That's okay. 5. I think that can work. But For the most part, it's all starting to feel pretty good to me. Huh. It's interesting. It plays the slope on that particular animation. I can't tell if I like that or not. Um, let's see here. Just one quick change for me. It's going to take a little bit. I'm going to pause it and open up the animation blueprint. Okay, we have the animation blueprint up. So I want to look for ledge stop. So for me, this is just a calculation of, should be a bowl here. Let's come here. So we're in ledge stop. So what is the rule for ledge stop here? Ledge detected and no acceleration. Okay. So that means that's the ledge stop. Okay, so let's make that a variable. Let's go to our event graph. I'm just gonna come out here. I don't think we're setting anything up here. Let's go to common vars. I have some function in here, set common vars. There should be something in here from our ABP, our blueprint. Ledge detected, here we are. So we're gonna take it ledge detected. It has acceleration. Well, that was these two right here. Could have just done that. And then we're going to say promote to variable. And then that variable is going to be named ledge stop. Nope, can't use that. Try is ledge stop. There we are. We've got our new variable. Let's put this somewhere. Let's put it down here. At the very end, we're going to say set ledge stop. Okay. Now that we have a variable, we can do a couple things. So I'm going to come here and just use that. Let's stop. And then pipe that in there. Then we can delete that. So we compile and save that. Then we can come back to our slope warping control rig file. And we can make a new variable is ledge stop. Then we want to make that instance editable. And then what do I want to say? How do I want to use this? I'm thinking, okay, I could use it in here with this quad and say is ledge stop. So an or bool here, that or this. And we want to say if here, ledge stop is true, we're going to make these values 10. If not, we'll make them a 6. So if we're ledge stopping now, if ledge stop is true, then that'll be a value of 1. And if acceleration is true, it will be a value of 1. So either way, I want to kind of ramp this alpha down, this multiplier down on this quadrant stuff. And if ledge stop is true, then we want to use a faster decreasing and accelerating value. Let's save that. We're going to come back to our ABP, come to our slope warping. I'm going to look for, let's stop here and add that. I'm going to say git is let's stop and compile. And we've saved it. So if we play here now, then it might be hard to see, but looks like we fell. Looks like we're just allowing less of that. So that's good. Less of that quadrant stuff. Trying to get to a ledge. I'm not even sure where a ledge is. So I think that's going to be it for today. So we added in a little bit of ledge stuff. We determined our quadrants and made value adjustments for our quadrants. We went through looking at all of our alpha values and looked at our extra offsets for the head and the spine. So hopefully that'll help you. I believe this is probably going to be my last video for slope warping. And hopefully you guys have learned a lot. I know I've learned a lot. And I appreciate you guys coming with me on this slope warping journey. Happy animating out there, and best of luck to you.